And hello, what we're doing today is one of my favourite things to do. I really enjoy these questions, is like related rates questions. And what that means is that you have different rates which are connected together, which influence each other and that sort of thing. And it'll make more sense once I start doing an example. But my tips for doing related rates questions, okay, is to firstly pay attention to the units. Okay, have a look carefully at the units, and they will help you. They will help you with the question. So look at the units that are being used. It'll really help. Remember, it's generally, I don't know a question that way. You'll always be to use the chain rule. The chain rule will connect those relates together, and so that will help you as well. Always draw a diagram. That will help you to think about the question and to understand what's happening. And also you'll need to think of, I guess, properties that connect variables. Okay, so that might be, Pythagoras. Pythagoras might be areas of triangles or something like that. Might be volume formulas, anything like that. Similar triangles often happens. Similar triangles, things that connect the variables together. So if you're doing a question that connects the volume to the height or something like that, you write out the formula. What is the formula that connects those variables together? Really important to write those things down. And they're probably my big tips for how to do a related rates question. So now it's hard to sort of show all types of examples. I'm just going to show one example here to give you an idea of what's expected, and I'll show some more difficult ones during class. So here's a question. We have a pipe here flowing with water into a tank. This is a cylindrical tank with a 6 meter diameter. So a cylindrical tank is being filled at a rate of this. Find the rate at which the height of the water is increasing. Now, it's hard to know where to start sort of with these questions sometimes, but it's always important to sort of start with what you know. Firstly, we've been told that the rate at which it's filling is this. Now, if you're not sure actually what that means, look at the look at the rate there. What is that telling you? 0.03 meters cubed per minute. What is meters cubed a measurement of? It's volume. What is minutes a measurement of? Time. Okay, so what this means is that the rate of volume over time, in other words, the change in volume over time, V over T, meters cubed over minute, is equal to 0.03. Okay, need to understand that, dV by dt. If you don't know, if you filled at a rate, does that mean, what does that mean, the height or whatever? Look at the units that that is in the answer, and that'll tell you volume over time, dV dt. Okay. What we want to do is find the rate at which the height of the water is increasing. In other words, what is the change in height over time? Okay. What is dH dt equal to? Find the rate at which the height of the water is increasing. So that's what we need to find. At this point, that's all you really know. We know that the diameter is 6 meters, but we don't really know. What we want to do next is to actually write down the chain rule. So for dH dt, no, I'm not going to write it down, I'll write it up here. Okay. What that will be equal to is write down the chain rule. So dH dt. There's the chain rule, and what you want to do is fill in the gaps here. Okay, what could you put into here? What do you already know? Well, we know dV dt is 0.03, so that's a good idea. Let's put dV in here to make dV dt like that. Okay, so down here we need to put dV, and that gives us our dH dt. The reason this is a good place to start is that now we know, to be able to find dH dt, all we have to do is find dH dV. In other words, the derivative of h with respect to v. So what we need to do now is find something. What connects v to h? Is there a formula that we know that will connect the volume of this water to its height? And in fact there is. What is the volume of any sort of cone like this? What's the volume of a cone? Well, the volume of this, sorry I said cone, cylinder, will be the area of the base times by its height. Okay, so our volume for this water level at any given height will be pi r squared, so that's the area of the base, so pi, our radius is 3, so 3 squared, pi r squared times by its height. So its height we're talking about here is the height of the water, which is that height there, h. So here is a formula that connects volume to height. Let's just neaten that up. That's 9 pi h. Excellent. Volume's equal to that. So we want dh dv, but we've only got vh. So what we can do is find dv by dh. In other words, the derivative of this with respect to h. What's the derivative of that with respect to h? Well, that's just, if you don't know, that's just a constant out the front. So that's like, what would be 3x? What's the derivative of 3x? It's 3. What's the derivative of 9 pi h? It's 9 pi. Okay, so there we go. That's dv dh. So what's dh dv? dh on dv is just that upside down, like we learnt a while ago. It's 1 on 9 pi. Therefore, back up the top now, dh on dt is equal to dh on dv, 1 on 9 pi, times by dv dt, which is 0.03. And this will be your rate. And let's just put that into the calculator. 1 on 9 pi times 0.03. So just delete all that rubbish. Okay, so what was it? It was 0.03. 0.03. I think it was 9 pi. I'll just check it before I go to it. 9 pi. 0.03 and 9 pi. Yep, that was right. Gives me 0.001. We'll leave it at that. Normally a question will tell you how many decimal places it wants and that sort of thing. 0.001. 0.001, and make sure you put your units of measurement in here. The height, well, our initial volume was in meters cubed, so your height must be in meters, and the time was measured in minutes. So it's increasing at 0.001 meters per minute. If you want to change that to centimeters to make it a bit more, or seconds or something like that, you could, if you wanted to. Depends what the question wanted to. So meters per minute, so it would be 0.1 centimeters per minute. Okay, or 1 millimeter per minute. So that's your answer there. That's how much the height is increasing. So, in summary, firstly, write down what you know. We know dv dt. Look at the units to figure out what that is. Secondly, write down what you want to know. We want to know dh dt, the change of height over time. That's what we're looking for. Write down the chain rule that connects the that will help get you the answer, and then figure out what you know. We know dv dt. We want to know dh dv, and so we're looking for something that connects the height to the volume. What connects those? This volume formula here, that connects the volume to the height at any given time. And then we just plug things in and get your answers. That basically is related rates. They're wonderful questions, very powerful. It's able to, you're able to use rates with each other really seamlessly, and it's used a lot in engineering and science and that sort of thing, with different things, with water filling, with flow rates, with speeds and distances, times, everything. So very, very powerful. Have a go.